And our next presenter is McCabe. He is from Purdue University, and his presentation is going to be circadian rhythm disruptions cause insulin resistance in transition dairy cows.
Thank you for the introduction, Dr. Worman. And in thinking about circadian rhythm disruptions, first we must define what circadian rhythms are. And they're endogenous 24-hour cycles in all mammals that are regulated by environmental events around them. And this can include the timing of events such as light, temperature, the timing of eating, and social interactions they have, among others. In our previous study where we disrupted circadian rhythm in cattle through light shifting, we saw that the animals that had a disrupted circadian rhythm produced more milk over the first 60 days in milk, yielded greater fat content over this period, and also had lower plasma glucose concentrations in the first couple of weeks postpartum compared to a control. And also, previous work in small ruminants has shown that circadian rhythm disruptions have led to insulin resistance during glucose infusions. And what I mean when I say insulin resistance, I'm saying that in order to put away the same amount of glucose into tissues from the blood, they need to use a greater amount of insulin to do so compared to a control. And so for our study, we started with 16 multiparous cows that were blocked to 2 treatments at 35 days as for expected calving of a control group and a phase shifting. Both groups received the same amount of light at 16 hours of light and 8 hours of dark for each 24-hour period. For the control animals, the light was from 5 a.m. to 9 p.m. every day, whereas for the phase shifting group, they had a shifting pattern of light every 6 hours every 3 days. And for example, by that, we mean that they had light from 5 a.m. to 9 p.m. for 3 days. And then 3 days later, the light was from 11 a.m. to 3 a.m. and it kept shifting forward in this 6-hour fashion every 3 days. From that previous study I talked about and previous work in small ruminants, we wanted to look at how these animals were affected and would respond to glucose challenge by performing intravenous glucose tolerance tests at 14 days before expected calving and 7 days in milk likewise. And so what we saw from these glucose tolerance tests is that there was no difference between groups in glucose response curves. So in response to the glucose challenge, there's no difference in the clearance rates or the time that it takes for them to put away all that glucose they were challenged with. However, there is a greater difference in the prepartum of insulin production and insulin area under the curve for the phase shifted animals compared to control. And therefore, this is why we see this development similarly in insulin resistance. The effect of circadian disruptions on insulin area under the curve was eliminated at 7 days in milk. It was only seen during the prepartum. And furthermore, how could this be a greater implication, and what does this insulin resistance matter? Is the control cows yielded a greater amount of milk in this study for the first 60 days in milk. So when we think about implications of seeing this difference in insulin sensitivity, and knowing that circadian rhythm disruptions have a negative impact on insulin sensitivity, and this was seen as the late gestation light phase shifting circadian rhythm disruptions had that negative impact. And we think that light is affected at the brain level, but then that is transmitted to all the different peripheral tissues, which control their own metabolism based on their circadian rhythm. And if it's disrupted at this level, it has an effect on the surrounding tissues. But we see that this treatment effect on insulin signaling was negated post-calving, as we see in the 7 days of milk. But these potential carryover effects of circadian rhythm disruption may have affected milk production. Plus, if animals are similarly insulin resistant they have a greater likelihood of increasing the amount of triglycerides and not be able to metabolize their nutrients as efficiently as they should. And therefore, maintaining consistency in the late gestation period and keeping a regular circadian rhythm is important for milk production and overall animal health.
Thank you, Connor. And if anyone has any questions, they can email Connor. His email is listed there. There is none in the chat box, but we've been going through them really quickly, so people may not be able to formulate questions in such a short amount of time.